Dobby, and I'm from the European Commission, from the Direct General for Translation. And as Lucas said, I'm joined here today by my colleague, Cristian Brasoveanu, who will be helping to answer some of your questions in the chat and in the Q&A session when I've finished the talk. Cristian and I are from the e-translation and AI language services team in DG Translation. And we're going to tell you about the work the team has been doing with large language models for generative AI. So together, Cristian and I coordinate a community in the European Commission called the AI at EC Network. Now, this network is a community at the Commission that was set up to identify and explore practical uses for AI technology. It's open to all staff, from business users to experts, technical experts, like developers, but also anybody who has a general interest in AI. We also have some members from a range of different EU institutions. And the main aim of this network, or the aims, is to identify new use cases for AI at the Commission, explore these ideas to develop new tools and new services, and then more broadly to build and share knowledge in the field of artificial intelligence. So today the network has over 2,000 members, and this number is growing by the day. So now let's talk about how we're using large language models at DG Translation. So AI is nothing new at the Commission or DG Translation. You may be familiar with e-translation. This is an online neural machine translation tool provided by the European Commission, and it launched back in 2017. And this flagship AI project is based on a partnership between DG Translation and the Directorate General for Communications, Networks, Content and Technology, or DG Connect. E-translation is intended for EU institutions, for public administrations, universities, freelance translators in the EU, SMEs, NGOs, and projects funded under the Digital Europe programme. And in recent years, the e-translation project has added more services. So it has speech transcription and other services for natural language processing. So that's available online. Now, the new large language models for generative AI have brought about dramatic change in our work and a whole new range of opportunities. So these really are the supermodels that potentially can give us the superpowers that we are talking about in the title of our presentation today. If you're not familiar with the field, this slide shows examples of the latest LLMs, including the ones used in applications like ChatGPT and Bard. So a large language model, LLM, is an AI model with a large number of parameters. And parameters in an AI model are loose analogues of neural connections in the human brain. So basically, the larger the number of parameters, the more capable the model is. And these general sort of large circles or different sizes of circles on this slide illustrate the size of those models. Now at DGT, we have access in particular to the GP models from OpenAI. So these are the same models powering ChatGPT and GPT-4, but they're available in a safe and secure way inside our Microsoft Azure cloud environment. We have a GPT lab to experiment with writing instructions for GPT models for various use cases, so writing prompts. And it also gives access to the most powerful GPT-4 models. So now we're going to show you a few examples of some of the specific use cases we've been exploring. Of course, DGT's core business is translation and including machine translation. So this seemed like a natural place to start. The focus here is to investigate how LLMs can help with machine translation, and we took an adaptive machine translation approach using fuzzy matches. We give the large language model examples of other translations from our database that are similar to the new sentence we want to translate, but they're not the same text. And then we include two or three of these fuzzy matches and the source text and target for each of the fuzzy matches, and then give the new source sentence and ask the target for the target text for that. So, so here's an example of how that works. You have this table with four columns, and in this example, we provided a source segment in the first column, then in the second column, the best fuzzy match from our translation database. And then in the third column, the e-translation output. And you can see in the final column, the fourth column, the GPT enhanced version. And you see that the model has been able to learn from the fuzzy match to slightly improve e-translation version, but that it's not perfect. It's also introduced an error. Now, the next example comes from our quality managers. So our quality managers, let's leave it there. Our quality managers are looking for errors when reviewing translation. And the first type of error they looked at exploring with large language models was errors with negation. So negation is when we change the meaning of a sentence by introducing a word like no or not or never so that it means the opposite of what we intended. And here we gave the model this the French source sentence and then five options for translations, two of which we know are incorrect because they have a negation. And then on the right, you see that the model was able to identify which three are the correct translations from this and which three are incorrect, and also to provide an explanation in each case of why the sentence is incorrect or correct and exactly where the translator went wrong. And now in this example, we looked at omissions and additions to text. And here the model read not from a text directly, but from an actual image of text. And here again, it was able to identify correctly from the image the errors or the omission in the first pair and the addition in the second pair of sentences. And again, to provide an accurate example of what was wrong in each case. So this brings me on to terminology and an example of how our terminologists have been experimenting with the GPT model. So here on this slide, they produced a prompt. You see it's quite long, an example of the instructions give to the model about how to write a good term definition. So it contains a list of all the rules they follow to write a really good terminological definition. And it provides them, or when you prompt it, you provide an example of a good definition and basically tells the model to act as a terminologist. And then in the example, when we run this with GPT-4 in the DGT GPT lab, you can see broadly the result is at the bottom in the colored box, that it produced a good definition and it broadly followed the instructions. And in particular, one of the instructions was not to add too much padding or fluff to the definition so that it's not overly verbose or too chatty. It's just simple and to the point. And it did that well. Now, our editing team have also been experimenting with how large language models could help with their editing process. And similar to the terminologists, they also produced a prompt. And you can see, again, it's quite long. it tells the model to behave as an editor, and then it includes the general clear writing principles and internal rules that the editors would follow in order to improve a source text. And then on this slide, you have the output from that. So on the left, you have a table with three columns, and in the left-hand column, you have the original text. In the central column, we have the text as edited by the model, and then the last column on the right is the human edited version. So what you see here is actually the edited version in the middle that the model produced is quite good. It's a good quality, but it's introduced maybe too many changes and some of them are unnecessary, and it's introduced some inconsistencies. And overall, it's made the text a little bit longer when editors would typically be trying to shorten the text. And it also was able to provide justifications for why it made the changes. For example, it's explained where it's added a heading to provide an informative overview of the content. Now, this is a different tool, eBriefing, a tool that we're working on, is in development at the moment and being explored through the AI at EC network. And it's a tool to create briefings, because one of the things that comes up most often if we ask staff across the commission what they think they might need help with in terms of AI, it would be writing briefings. So you see here that we have an e-briefing lab. There's a prompt already written that follows the instructions provided by our briefing service in this experimental environment. And I mean, this is a screenshot of the experimental environment, in fact. And you can upload some input files, maybe 4 or 5 files, and um, enter your topic and questions, choose your AI model, and then adjust how creative you want the model to be when it produces your briefing. So the instructions we give the model about how to write the briefing are based on the input documents and the topics, and they incorporate all these in-house principles on writing briefings. And here we have an example of e-briefing output from the lab. So you can see that it's included some main messages from the input text we provided. It's produced questions and answers, and then further down some more background. However, what we're finding so far is that the model doesn't always comply with all of the formatting instructions. So this exploratory work is ongoing at the moment, and here we're really leveraging the members of the AI at EC network to experiment with writing the best possible prompt to produce the best result at the end. And that's a product that we hope to put into service in the near future. So, of course, all of this experimentation and exploratory work leads to the inevitable question of, should we be building our own LLM, large language model, or an LLM for the EU by the EU? And why would we want to do this? Well, our colleagues at the Council of the EU published a report earlier this year on the specific risks to the public sector of the use of generative AI. And in addition to the risks that are inherent in the nature of generative AI, such as inconsistencies and inaccuracies, hallucinating, and so on, there are also risks about accountability and costs, bias, and to what extent the creators have influenced the model. And on top of that, there are potential copyright infringements in the way the data, in the data that was used to train the model in the first place. And we find even the open source models same risk. So many larger organizations are considering whether they should have their own corporate large language model. Building your own model would give us greater control over what goes into the training data and how it's run. However, building or even tuning our own large language model for Europe could be a large scale, very computing intensive project. At DGT, we do have a new supercomputing project that's aimed in that direction through the Euro HPC network of supercomputers, which is funded by the EU. The e-translation team at DGT had a first supercomputing project in the early part of 2023, which was a first for any in-house project at any EU institution. So that was on the Meluxina supercomputer in Luxembourg, which is one of 8 supercomputers in the Euro HPC network. And this project was about training larger models for machine translation. And we are now starting a new project involving training open source large language data. So supercomputing power can help us have a supermodel with its superpowers that's completely under our control and fully meets EU guidelines and it matches with our rules and values. So we think that this could be the future. Thank you. So if you would like to ask any questions, and Cristian, are you?
There has been only one question so far in the chat, which was about the ITC network, and maybe just for clarification, that's an internal network for the European Commission primarily, but also open to other EU institutions. So if anybody in the audience is from the Commission or from one other EU institutions, of course, just get in touch with us and we can add you. But yeah, it's an internal network.
So while we are waiting for the other people to start asking, maybe I can start with my question. And that would be, if I want to start my own AI experiment, what will be the hardest to get? Will it be the supercompute, or will it be the people, or will it be the data?
Well, if I can take this one, you can say all of them. It's the magic triangle, right? It's the computing resources are very sought after at the moment, and of course, for example, Meluxina has only A100 GPUs at the moment, and there's an entire competition at the global level to buy all the new generation of H100. But this program that the EU started already a couple of years ago, the Euro HPC joint undertaking, which brings together not only the Commission, but also member states and also private actors. This has been a major investment in infrastructure of this kind in Europe. Of course, it was traditionally more for what we can call more conventional supercomputing, for large-scale modeling. But now, yes, with the rise of the new wave of AI technology, you've probably seen that also in our President's State of the European Union address, there was a reference that there will be a new initiative to open it also to startups to train specifically AI models. Data is a challenge as well, not necessarily that there isn't a lot of open source data like mountains, but there are issues with the quality. And this is, of course, something that in our case, what we have internally in the translation database, for example, and in other sources, it's very high quality data. With these large language models, of course, the fact that it's translation data, aligned data, is not that relevant, but it's important to have multilingual coverage because, as you know, some of these models are not very good at some languages, at least not yet. And the skills, we are at an event about skills for excellence, and yes, skills for working with such technology, for working with the infrastructure involved in this, with the data, and then running this technology, because you can build an LLM, but running an LLM is not a small business either, are in very high demand. And there is sometimes difficulty to recruit people with the right skills. And I think there's a lot of opportunity to acquire those skills as well, in addition to other language-related skills.
Thank you very much, Cristian. There are 2 more questions in the chat now. if you'd like to take them. So first is from Gisela Bernish. Is there any website where updates on your work are publicly available?
We do publish updates when we have additions to our services on the Digital Europe Language Tools website. That's direct access to the language tools, and people who register to get access to the language tools, when they receive notifications every time there are additions. But the more exploratory work, we don't keep like, and it's also very moving very fast. Like you have to adapt very quickly. We don't have an external website for that, but we do participate in presentations that are also external, like this one, this event, and other events, and we share what we have, and we think it can be of interest.
Thank you. There is Rafael Prono asking, could you please repeat the number of GPUs necessary for this LLM to work?
That's a question that depends on the size of the LLM and how high you can go. I mean, if the smaller ones, I think you can get away with one or two machines that are still quite large. Maybe some machines that may have 8 A100 GPUs. So that is a large machine in terms. But what we showed in the slide is not so. That project on the Meluxina supercomputer is not about using the full supercomputer or using it fully to run the LLM. It is about training models, and the number that we showed was 800 because this is what they have at the moment in the GPU partition of Meluxina. They have 800 nodes, each of them with 4 GPUs. And you can normally use up to 20% of the capacity in one typical training job. If you have really large scale project, then there are special extreme scale types of access and arrangements. But in terms of running, it depends a lot on the size. Of course, we don't have official information about GPT-4, for example, but GPT 3.5 or the Bloom model, which was built in Europe, I think they needed up to even maybe up to even 18, 20 machines to run one instance of the model at a time.
Okay, there is a question from Dragos Giobanu. Some unit trainers say that neural machine translation is better than some trainee translators, but also that it makes the best ones worse. Is there any evidence about how the services you mentioned help or hinder the acquisition of skills needed to check the output?
Yeah, well, this is a very big question. I mean, there are many different angles in this question. Yes, there is the so-called falling asleep at the wheel. You get used and you assume that you get some good results. And until now, maybe it was primarily in machine translation, but now it's going to be everywhere. And you've probably seen already stories in the news where some people in some companies, government, they just generated something very quickly and they just submitted a document, and then there were hallucinations and references that didn't exist. So I think you've seen plenty of those.
We've all seen that.
Yeah.
So,
and this is another big question about helping or hindering the acquisition. So the skills needed to check the output. Yes, it's like with all other technologies, I suppose, since the beginning of time, it's in the hands of the user what they do with the tool. If they just rely completely on the tool, or make it really just a tool, just using it critically and effectively. And in our internal guidelines for the use of such tools, we do have some of the rules that are specifically aimed at this, so that we try not to hurry things and use a tool like this and just generate something and assume that it's okay, and then cause some other harm further down in some other people's hands.
Oh, thank you. For this one, for the question from Dragos, I can also say, because I'm a translator and I'm a user, you are more of a developer of this translation tool, and I'm a user of NMT. And I can see that I don't think that any of my colleagues is getting worse as a translator because we are using NMT. Um, sometimes, if we have to rush a lot, of course, we will rely on the NMT and it might make our translation worse than if we hadn't used it. But if we hadn't used it, we wouldn't have been able to produce a translation in the first place. So it's just about the amount of effort that we could put into it. I don't think it makes us worse. So there's that. There's one more question from Agnes Leonovic. I'm sorry if I'm mispronouncing the name. Do you expect quantum computing to be a game changer in LLM training in the future?
Well, I assume it will be a game changer for everything. It remains to be seen in one way. So, I mean, I'm not myself an expert, and I have been following what is happening in the field, and so far what I have seen mostly arguments that we should not expect quantum computing to be part of the kind of consumer or user-facing computing, but rather for very specific tasks somewhere in the background. But I assume that it's going to change everything, and that includes not necessarily LLM training. I mean, who knows what kind of model or what kind of technology we'll have in just a short period of time. Even with LLMs, as you have seen probably in some publications, are becoming LMMs. There was a paper by Microsoft about the rise of LMMs because they are large multimodal models, model with an
Okay.
A. So yeah, I don't know for how much longer it will be about language models, because of course it's still language, but the fact that they work with images and audio and all type of inputs, it makes them going a little bit beyond just text-based language, at least.
Okay. I would say that for the question as well, the quantum computing will make a lot of changes to IT, but I've heard you claim that AI is not IT, so we'll see about that. Translators from Yvonne Tsai. Translators may now require skills to work with LLM for generative AI. What training do you think universities can provide to help translators cope with the rapid development of technology? Is there a way?
I think definitely, as we will probably discuss later during the day today as well on the panel later this morning, definitely there is a need to have a very good understanding of this technology and how it works a little bit, and the limitations and the capabilities as well, because it's going to spread all around us. I mean, it's already been spreading. We have been having machine learning based functionalities around us even without knowing for a long time. But of course, this is a new level. It's a new wave with new capabilities and new risks as well. I would say that at least this kind of understanding is definitely necessary. Now, working with LLMs, the part about what is called prompt engineering and writing good instructions, from what we've seen so far, I think the best instructions come from the experts in the field rather than the developers creating the applications that use those LLMs. So I think that's where the power is for the translators as well, when they work with such technology to be able, for example, to create personalized assistants that are maybe writing in a certain style and using certain rules that the translator in question works with, and so on. So both understanding and how to get the best out of an LLM are, I think at the moment at least, are the two main parts. Building LLMs, I think it's a much larger scale project that maybe not everybody will do that, but it's definitely important to be able to be a what do we call that, Lucas, for jump at an AI whisperer, if you like.
Oh, yeah, that's a nice one. We have time for one last question before we need to leave. So that would be from Timea Palotai Torzaj. In an AI-driven translation workflow, do you think there will still be the need for human verification based on curated reference data?
At the moment, definitely. I mean, there is no, as you know, this technology is all based on probabilities, which means that you can never have a 100% guarantee. So it depends a lot on the use case. And in the use cases where you need that kind of guarantee, you cannot rely on these models to be absolutely sure that they are not producing something false. There is a lot of research from what we see in the news and publications to try to improve, to connect it with world models that check what the LLM says, and with other resources like knowledge bases and knowledge graphs and so on, to try to validate an output of an LLM. But so far, we haven't seen a setup that can give a 100% guarantee. And some use cases, less than 100% guarantee will not be acceptable. So definitely, there is a need to have human verification.
Thank you very much for that, Cristiano. For that, if anyone's interested in this, as you mentioned that AI is based on statistics. Yesterday, there was a very interesting panel with Beate Kuhl about data management, where she was talking about statistics just being a way of dealing with uncertainty and about the need for verification, just like Cristian mentioned now. With that, I would like to thank you both very much for your presentation. And I would like to invite you all for the next breakout sessions that will be taking place today after the main sessions. Thank you very much. Have a nice day.
Thank you. Bye.